Alright, so let's suppose that f and g are continuous on an interval from a to b, and the y-coordinate for g is smaller than the y-coordinate for f, and they're both bounded by the vertical lines x equals a and x equals b. That's your boundaries, so we're bounded by a and b. And then the area between the two curves is from a to b of f of x, which is your larger function, the function on top, minus the function on bottom. So here's some steps. If you want to find the area of the region, you want to sketch or draw the graphs because you need to know which one's on top. Determine if you need dx or dy. I'll talk about what dy is going to be in the next video. Vertically, it's going to be respect to x, horizontally, respect to y. Number 3, find the limits of the boundaries, axes, or intersections. That's your a and b. Set up the integral by top minus bottom if dx, or right minus left if dy, and integrate and evaluate the integral. Alright, number 1, find the area of the region in the first quadrant that is enclosed by the graphs of y equals x to the third plus 8 and y equals x plus 8. So let me sketch a graph here. So we're talking about the first quadrant. Alright, a cubic looks like this, but we're only concerned about the first quadrant part. And then your linear looks like that. So we're talking about this region right here. So we need to figure out where they intersect, and you find the intersection by setting them equal to each other. So if your y-coordinates are the same, that means you just set your two functions equal to each other because they're intersecting the same y-coordinate. If that makes sense. So I have x to the third plus 8 is equal to x plus 8. If I move everything to the left, I get x to the third minus x, and my 8's are going to cancel. And so if I factor out an x, I get x to the x squared minus 1. So that gives me, this is a difference of squares, so x plus 1, x minus 1. So x can either be 0, -1, or +1. Well, the only ones that I have to worry about in the first quadrant are 0 and then 1. And so if I set up my bounds, I'm going from 0 to 1. So the area between the curves goes from 0 to 1. Those are my points of intersection. And we're going to do our top function. Well, if I run my finger down the page, you'll notice that my top function is the blue function. So it's going to be I'm going to do x plus 8 minus my bottom function, which is my cubic, x to the third plus 8. And if I distribute my negative and cancel, I'm just going to be left with x minus x to the third. Your 8's are going to cancel. And so now I can just integrate. And so that gives me x squared divided by 2 minus x to the fourth divided by 4. And we're evaluating those from 0 to 1. And so if I, just to notice, if I plug in 0, I'm going to get 0, so I'm not really worried about my lower bounds. My upper bounds, if I plug in 1, I'm going to get 1/2 minus 1/4. Well, half minus a fourth is a fourth, and so that's the area between the two curves. Alright, the area of the region, bounded by the lines x equals 0, x equals 2, y equals 0, and the curve y equals e to the x over 2 is, and so if I draw a quick sketch here, the curve y equals 0 is actually just the x-axis. The curve e to the half x looks something like this. It's the e to the x. Again, we're just looking for a sketch because we want to know which one's our top function, which one's our bottom function. If you're not really sure, you can plug in points. So you could plug in 0, plug in 1, plug in 2, and then kind of plot all those points if you're not sure about the function. And then we have x equals 0. Well, x equals 0 is the y-axis. And then we have the line x equals 2. And so what we're looking at is this region right there. So our bounds are actually going from 0 to 2. my top function is the red function, so e to the x over 2. And then I'm going to subtract my bottom function, which is y equals 0, so I'm just going to subtract 0. So if you notice, this is kind of what we've been doing this whole entire time, just taking the antiderivative with respect to x with the area under the curve. And so, don't let this y equals 0 fool you. Okay, so that's what we've been doing this whole entire time, is taking the antiderivative. So I have 0 to 2 of e to the x over 2 dx. And so I'm going to use u substitution. So I'm going to let u be x over 2. That means du is 1/2 dx. So that means dx is 2 du. And that also means I need to change my boundaries. So my a sub u, if I plug in 0 into this function up here in my u function, I'm going to get 0, because that was my lower boundary. My lower boundary for my b was 2, so I'm going to plug it into that u function. So I have 2 over 2, which is equal to 1. So my new boundaries are going from 0 to 1. This is e to the u times 2 du. So that gives me 0 to 1 of 2e to the u du. So we can go ahead and take the antiderivative. This gives me 2e to the u evaluated from 0 to 1, which gives me 2e to the 1 minus 2e to the 0. Well, that's just 2e minus 2. Alright, number 3, we're going to be using our calculator. Find the area of R in the region of the first quadrant closed by the graph that f of x is equal to 1 plus sine of 2x, and g of x is equal to e to the x divided by 2. So I'm going to plug in f into my y1, so y plus sine of 2x. And then just so you can see it better, I'm changing the line, so you just kind of scroll over to y2, scroll to the left, and hit enter. And then I'm going to do my second function for my g, so e to the x divided by 2. And I'm going to just take a look to see what it looks like. And so that's a little hard to see, so I'm going to zoom in. Alright, and so you can see we have two intersections. I actually have two areas. I have an area in the second quadrant and an area in the first quadrant. So I need to find what all those intersections are. So I'm going to do second trace 5, which gives me intersection, and so I'm going to go over to the intersection I'm getting close to. So it's close enough. So there's my first curve, there's my second curve. And so my intersection is negative 1.318. So I'm going to do second quit. And so I have negative 1.318. If you want it around, you can. And I'm going to store that into A. So store, which is above the on button, and then do alpha A. And so that way I don't have to remember that number. It's already sorted into a letter. So I'm going to do, again, go to second trace. I want to find the intersection. So now I'm going to find the middle intersection. It looks like it's going to be at 0, but just want to, double check. So scroll your spider so it's close enough. And so go ahead and do enter, and then our intersection. So that's really darn close to 0, e to the negative 14. So I'm just going to call it. I'm going to say it's 0. So now I want to find what my next intersection is going to be. So second trace 5, and so my intersection, get a little bit closer to it. First curve. Ooh. Not sure what happened there. Alright. First curve, second curve, guess, sure. And so my next intersection is 1.135. So second quit, so 1.135. And I'm going to store that into B. So it makes it easier when I do my Math 9. So now I'm going to do, I need to figure out which one's on top. So I'm going to go back to my graph. If you notice, my e to the x, which is stored in y2, hold on. Sorry guys, my son just left. Alright, so looks like my top function is going to be my y2, and my lower function is going to be y1, and those will reverse. Those are reversed in the other quadrant, so I'm going to do second quits. And then math 9. And so I'm going to do variables next to clear, y variables, and I'm going to do my y2 minus my y1. Comma x, comma independent variable. And so now remember my lowest one is a, so I'm going to do alpha a. That's that negative 1.318. And then remember it crosses at the x-axis, so 0. And I'm going to add that to the other area. So notice there were two areas. Area in quadrant 2 and area in quadrant 1. So that means I'm going to have two integrals because I have two areas. So I want to find that total area. So I'm going to do math 9 again. And then again go to variables, y variables. And now it's going to be y1 minus y2 because the graphs have switched. And then comma x, comma 0, comma, and again our intersection at the very end was b. And then we can go ahead and hit enter. And so there's our area, 1.013 or 1.014.